to derive beta hat, let's talk about how to calculate it in a very simple setting. So an actual explicit formula for beta hat in the intercept only model is what we're going to be doing now. So the intercept only model is basically this model here. So we've got y equals beta naught plus epsilon. And so this y here is going to be a vector from y1 to yn. So we have n elements of y. Beta naught is the thing we're trying to estimate. And then epsilon is going to be a vector from epsilon 1 down to epsilon n. So in this setting, what do you think our design matrix X would be? So recall that X is, in the design matrix formulation, is a matrix where the first column is all ones and the subsequent columns are the values for the predictors. And so in this setting, we don't have predictors, but we still have our column of ones. So we've got this column of 1 where we have n elements, all of 1. Okay, so that's X. So now what do you think X transpose X would be? So that's going to be, if we transposed this vector of ones, it would look like this. That's what the transposed version looks like. So we've just flipped it, transposed it, and now we're going to multiply it by this vector here, X, that we have there. So this is X transpose X. So how would we do this? Let's walk through this matrix calculation here. So if we're doing matrix multiplication, you multiply the first element of the matrix on the front by the first element of the next matrix. And so it's going to be, let's write this out here. So we've got X transpose X is going to be equal to 1. And then the next element is going to be 1. So 1 plus 1 all the way to this last element, or the nth element of 1. So we're going to be adding up n elements of 1. So we could also write this out as basically, so we got 1 plus 1 plus 1 plus 1 plus 1. So this is going to be the same as just writing n, because we're going to be adding up n elements of 1. So X transpose X here is just equal to n. Okay, now let's remind ourselves of what this beta hat formula that we've calculated is. So beta hat that we derived is X transpose X inverse X transpose Y. So what does it mean? If X transpose X is just n, it's just a scalar, how would you take the inverse of a scalar? The inverse of a scalar is just 1 over that number. And so we can write this. Let's see, this part here. This is just 1 over n. And then what is X transpose? That's just this vector of 1s. And what is Y? Well, that's a vector of Y. So let's write that out. So we've got 1 times our vector of Y. So we have 1 over n times this vector of 1s times this y1 to yn. So let's do the matrix multiplication here. So we've got 1 times y1 plus 1 times y2 plus 1 times y3 all the way down to 1 times yn. So what would be an easier way to write this part? Well, that's equivalent to just summing from I equals 1 to n of yi. Because we're taking y1 plus y2 plus y3 plus y4 all the way up to yn. Okay, so putting that all together, we have 1 over n plus the sum of yi from 1 to n. What does that look like? It's the mean. So that's just taking the average. So in this simple intercept-only model, our beta naught hat is going to be equal to the sum from I equals 1 to n of yi divided by n, which is equal to y bar, or the mean. So there you have it. So this is always going to be true. In intercept-only models, our estimate for beta hat, or our estimate for that intercept, is just going to be the average value for y, the mean value for y bar.